This over here is the sun. It is the star that powers the very existence of all life on Earth. As you have might read in textbooks, it is essentially a hydrogen bomb, with pairs of protons slamming into each other at high speed and fusing, triggering a chain reaction which fuses 4 protons into helium. This releases immense energy which powers the star. However, if this is the case, why doesn't the sun just detonate into the largest explosion of a hydrogen bomb ever and erase Earth completely? Well, it's actually pretty simple. The sun's core just isn't hot enough. Despite being at 15 million degrees, it is actually pretty cold for a proton. For protons to fuse classically, the temperature in the sun's core would need to be about 1 billion degrees. So this brings us to another question. Why is the sun not collapsing on itself with no way to counteract gravity? The reason is that because fusion still occurs. But how? To understand that, we need to dive deeper into the quantum world. Protons traveling at high speed occasionally head directly towards each other. However, due to the extreme repelling forces between protons, they are blocked by the Coulomb barrier, which is basically the repelling force between their two positive charges. This causes them to repel and not fuse. However, a particle can also behave as a wave, and the particle's position will not be fixed but will be a chance, a probability of the wave's amplitude squared. When the waveform of the particle hits a barrier, the wave's amplitude decreases exponentially, and even if the wave manages to be on the other side of the barrier, there is an infinitesimally small probability of the particle being there. And so if the particle happens to be there, then it tunnels through the barrier, which causes the two protons to fuse and they produce energy. Despite this probability being extremely small, the vast amount of particles in the sun balances out and produces a steady, burning star that powers our entire planet.